Hey guys, today we're going to look at our next factoring method. The first one that we talked about was factoring using the greatest common factor, GCF. Now we're moving on to when we have quadratic trinomials that when the first coefficient is 1, there's another way that we can factor those. So remember, a quadratic trinomial is a polynomial that has 3 terms. That's the trinomial part. And quadratic means that it has a degree of 2. So the highest exponent on your variable in the trinomial is a 2. So let's take a look. And what we have to remember is that when we're talking about factoring, we are essentially undoing the multiplication. So let's remind ourselves what it looks like to multiply. If we have 2 binomials that we are multiplying, we take the first term and multiply by distributing to everything in the second polynomial. So x times x. Remember, when we're multiplying, we add those exponents. X times x gives us x squared. 1 plus 1 is 2. Then x times -3 gives us -3x. And now we distribute the second term to everything in the second polynomial. So 5 times x is positive 5x. 5 times -3 is -15. Once we distribute everything out, then we look to see if there's any like terms that we can combine. Well, we can see here in the middle, we have -3x plus 5x. They are like terms, so we can combine those. -3x plus 5x gives us a positive 2x. I can bring down my x squared. I can bring down my -15. And check to see if my answer is in standard form. X squared plus 2x minus 15. Highest exponent, 2, 1, 0 exponent. So that would be in standard form. So that was a reminder on how to multiply. Factoring, we're going backwards. For factoring, we are starting with the quadratic trinomial, and we're going to figure out how to come up with the 2 binomials that were multiplied together to get that. So we are going to undo the multiplication and get something that looks like this for factoring. Now I'm going to switch gears for a second, and I'm going to give you a challenge. What pair of numbers will multiply to give us the top number, -15, and combine, meaning you add them together, to get the bottom number, 2? So take a second, pause the video, try and figure out 2 numbers that multiply to give you -15, but combine to give you +2. Hopefully you came up with 5 and -3, or -3 and 5. Doesn't matter what order. Commutative property of multiplication, they can be in a different order and get us the same thing. 5 times -3 is -15, and 5 plus -3 gives us +2. So now you're wondering, why did we just do that? If we take a look back, you'll notice I had a +5 here and a -3 here. Those are the 2 numbers that we just came up with. Something you might also notice is at the top of that x on the next slide, I asked you to find 2 numbers that multiply to give you -15. Notice that was in our trinomial. And that combined to give you +2. That was the middle number of the trinomial. This is going to be the strategy that I want you to use to set up in order to factor these quadratic trinomials. You take the last number that was in your trinomial, rewrite it. So this was our answer after we multiplied out. If I gave you this quadratic trinomial and I asked you to factor it, what you're going to do is you're going to set up an x where you will put the last term, your constant, will go in the top of the x, and the coefficient of your middle term actually, let me do this for a second. Whoops. I'll have to fix that too. There we go. Okay, so let's keep that positive with it. That's why I changed that. So positive 2, the coefficient of your middle term will go on the bottom of your x. Once you have the x set up, then I want you to follow those directions that are at the top of the page. What pair of numbers multiply to give us the top number and combine to give us the bottom number? Once you come up with those two numbers, you fill them in the x, and that's what you're going to use in order to write your factored answer. So first thing I'm going to do here, I know that I'm going to have two binomials, so I want to put my parentheses there. The only way that x squared can be split up is into an x and an x, because remember, we are undoing the multiplication. X times x multiplied together gives me x squared. So going backwards, x squared splits up into x and x. Then I'm going to use those two numbers that we came up with in our x. We had positive 5. Write that in one set of parentheses. And we had negative 3. Going to write that in the other. This is our factored answer. Or if you said negative 3 and positive 5, this is also the same answer. Right? Again, commutative property. The order doesn't matter when we're talking about multiplication. So you could have x plus 5 times x minus 3, or x minus 3 times the quantity x plus 5. So let's try some more. So we have x squared minus 13x plus 36. Let's set up our x. I take the third term, right, the constant back here, and that is what I'm putting on the top of my x, 36, positive 36. Then I'm going to go ahead and take the coefficient of my middle term, and that's what goes on the bottom of my x, negative 13. Then I want to come up with two numbers that are going to multiply to give me positive 36 and combine to give me negative 13. So again, pause the video, try and come up with two numbers that are going to multiply to give you positive 36 and combine to give you negative 13. Hopefully you came up with negative 9 and negative 4. Negative 9 times negative 4 gives me positive 36. Negative times negative is positive. And negative 9 plus negative 4 gives me negative 13. So that works out. And then I will use that to write my factored answer. The only way x squared can be split is into an x and an x. And then in one set of parentheses, I'm putting negative 9, and in the other, negative 4. So the factored answer for this is x minus 9 times the quantity x minus 4. Or again, the other way around, x minus 4 times the quantity x minus 9. If you would want to check this, all you would need to do is redistribute mentally, and you should end up back with this trinomial. X times x is x squared. X times negative 4 is negative 4x. Negative 9 times x is negative 9x. Negative 9 times negative 4 is positive 36. And then I combine my like terms. Negative 4x minus 9x is negative 13x. So we would get x squared minus 13x plus 36. That's how you check. Let's try the next one. Y squared plus 2y minus 24. I will set up my x. Negative 24 goes on the top. Positive 2 goes on the bottom. And then come up with two numbers that multiply to give you negative 24 and combine to give you positive 2. If two numbers are multiplying to give me a negative, I know one of them has to be negative and one of them has to be positive. So the two numbers we are looking for there are 6 and negative 4. So if you came up with the 6 and the 4 and you weren't sure which one had to be negative, that's where this sign tells you. If I made the 6 negative and the 4 positive, when I combine them, negative 6 plus 4 gives me negative 2. I needed a positive 2. So the larger number needed to be the positive. Okay, so once I have that, we can go ahead and write our factored binomials. Keep in mind, this time we're talking about y's. So I need to flip it into y and y. And then I use my answers here, positive 6 and negative 4. So y plus 6 times the quantity y minus 4 is your factored answer. Okay, let's keep going. Set up our n squared minus n minus 56. So negative goes on of the x. Now this sometimes can be a little bit confusing for people. Oops. My goodness, I'm having all sorts of trouble today. Where were we? Here. There we go. So we see this negative, so what coefficient is in front of that n? It's a negative 1. So on the bottom, I have a negative 1. So we are trying to come up with two numbers that multiply to give us negative 56 and combine to give us negative 1. Okay, that's going to be negative 8 and positive 7. Negative 8 times 7 gives us negative 56. Negative 8 plus 7 gives us negative 1. Then I can write my binomial. I don't think at this point you need me to be doing those colors anymore. So n squared, I want to make sure I have my n's in here, and then I follow the signs. I had negative 8, so minus 8, and positive 7 plus 7. And there is our factored answer. Okay, let's take a look at the next one, d squared plus 16d plus 15. So if I draw my x, put positive 15 at the top, positive 16 on the bottom. And at first, you might look at this and say, that's not possible. The bottom number is larger than the top. However, this is possible. So take a moment and think of all the factors you have for 15 and see if there's any that will add up to 16. And if your multiplication skills aren't quite as good, then you might need to actually write them down. So if I start with 15 and I list my, well, I have 1 and 15, I have 3 and 5, and those are all the things that I have that multiply to give me 15. Well, if they're multiplying to give me a positive and they're combining to give me a positive, I know both of my factors have to be positive. So 3 plus 5, that gives me 8. That's not what I'm looking for. 1 plus 15 gives me 16. That is what I'm looking for. So that's the pair that worked. That's what I put in here. 1 times 15 is 15. 1 plus 15 is 16. And then I can write my factored answer. Again, this time we're talking about the letter D, so make sure that's what you're writing. And then we have plus 1 and plus 15. And there's our factored answer. So what else might you see? This one looks a little bit different. I said that we were factoring quadratic trinomials. Well, if you look at x squared minus 25, that's a quadratic binomial. So let's take a look at how we can still factor that one using this method. We set up our x. Negative 25 is our constant. That is the last term that still goes on the top. What we're missing here is our middle term. We have an x squared and we have no x, but we don't have just a single x in the middle here. The only way that that will not be there is if it's a 0 x. So truthfully, this trinomial is x squared plus 0x minus 25. So when we're looking for that bottom number, in this case, it's going to be 0. That's the only reason it's not showing up there. So we're looking for two numbers that multiply to give us negative 25, but combine to give us 0. And again, that is possible. If I have two numbers being multiplied to give me negative 25, let me start with what multiplies the factors of 25. So I have 1 and 25, and I have 5 and 5. So I know that I am looking for two numbers that multiply to give me a negative. That means one has to be positive and one has to be negative. So if I look at this first pair, if one is positive and one is negative, there's no way for either of those. If this one's positive, that's negative, or if this is negative and that's positive, there's no way that's going to equal 0 when I combine them. However, if I look at this one, 5 and 5, if I make one negative, negative 5 plus 5, that will equal 0. That is the one that I'm looking for. So factored binomial, we're talking about x's again. I have minus 5 in one set of parentheses and plus 5 in the other. And that is our factored answer. Okay, let's look at the next one. B squared minus 3b plus 15. Set up x, positive 15 on the top, negative 3 on the bottom. Looking for two numbers that will multiply to give me positive 15 and combine to give me negative 3. Well, if I write my factors for 15, I have 1 and 15, I have 3 and 5, and that's it. If two numbers multiply to give me a positive, they have to be the same sign, so either both positive or both negative. If they combine then to give me a negative, then that means both of them have to be negative. So whatever I'm looking for here, both of my numbers would need to be negative. So negative 1 plus negative 15 is negative 16. That's not what I'm looking for. I'm looking for negative 3. Negative 3 plus negative 5 is negative 8. That also didn't work. I listed all of my factors for the top number, and there was no combination that gave me the bottom number. So if there's nothing that works, that's where we come back to prime. It cannot be factored, right? So prime or not factorable. So that is a possibility with this type as well. And let's look at one more example. So the different thing about this last example is this 2 up front here. If you look back to the title of this lesson, it says factoring polynomials when a equals 1. I haven't really addressed that, what this a equals 1. A is the leading coefficient. It is the number that is in front of your first term, right? The coefficient here. So for all these other problems, that was a 1 because there was no number that we saw there. However, this one, it's a 2. So as of right now, the only way that you can move forward with this problem from what I've taught you so far is if there's a GCF that you can take out first and get this number down to a 1. So let's look. Is there a GCF for this trinomial? Well, I have 2, negative 22, positive 48. They all have a factor of 2. I can take that out of every term. Let's look and see if there's anything more I can take out. This has an x, this has an x, and this has an x. They all have the variable x, so I know I'll be able to take some type of x out. Let's look at the exponents. X to the third, x squared, x to the first. Remember, that's a 1. So the most I can take out, the most they have in common, is this 1. If this term only has 1 in it, that's all I can take out of it. So the GCF of this trinomial is 2x. I'm going to divide that out of each of these terms. So 2x to the third divided by 2x leaves me with x squared. And again, this is referring back to what we learned in the last lesson. If you need to go back and review that, the video is still there. Negative 22x squared divided by 2x gives us negative 11x. And then positive 48x divided by 2x gives us positive 24. So I factored out a GCF. Last lesson, that was all that you knew how to do. Now, after this lesson, we can take this further. We can now use this x method to factor the trinomial in the parentheses even further. So set up our x, put the positive 24 on the top, negative 11 on the bottom. Okay, and just to come back here, the reason we didn't start with this again was because this coefficient wasn't 1. This only works when our leading coefficient is now a 1. So we're looking for two numbers that multiply to give us positive 24 and combine to give us negative 11. That's going to be negative 8 and negative 3. So this trinomial factors into x minus 8 times x minus 3. And what you have to be very careful of here is that you don't leave your GCF behind. That still is in the problem. So if you factor out a GCF, it just kind of comes along for the rest of the problem. Don't drop it off. So our factored answer for this one is 2x times the quantity x minus 8 times the quantity x minus 3. And if we were to multiply that all back out, we would end up back here at 2x to the third minus 22x squared plus 48x. So those are the different things that you might possibly see here. So your assignment, there is one assignment, it is a quiz. There are 20 multiple choice questions. You can see any of the types of problems that I covered in this lesson today. So if you need to, come back and check this out again. So I made it unlimited attempts so you can resubmit. Again, if you are not happy with your score after the second time that you take it, please reach out to me either by email or stop into my office hours or schedule an appointment to Zoom with me if my office hours don't work for you. Hey guys, keep up the great work. I'm happy with what I'm seeing, and I will see you next week.